Welcome to the Architecture Corner.
Great to be here.
Today we're taking a look, sort of under the hood, at something many of you are probably grappling with. Using a service like AWS step functions.
Yeah, not just in theory, right, but actually living with it, scaling it, maintaining it in, a real production environment for over a year in this case.
Exactly. We've got some fantastic source material today, reflections from a principal architect. They compiled lessons learned, feedback from various teams, basically what happened after they'd put step functions through its paces.
Like a real-world report card. What actually worked, what hit unexpected snags, and maybe what just felt a bit clunky.
That's the perfect word, clunky.
Yeah.
So our mission today is to unpack all that experience, pull out the absolute must-know insights for you.
Yeah, if you're using step functions or thinking about it, or even just curious about, modern workflow orchestration and practice.
This is for you. Let's dive in. They broke it down nicely. The good, the bad, and, well, the ugly.
Sounds like quite the journey. Okay, starting with the good. They really highlighted its strengths as, well, either a microservices orchestrator.
Kind of guiding tasks across different services.
Right. Or just as a really powerful, low-code visual workflow tool. They found it especially good when, say, your functionality is spread out across distinct components.
Okay.
Or maybe it needs human interaction, like an approval step.
Right.
Or it depends on services that might take a really long time. Hours, maybe even days.
Right. Coordinating those complex, long-running processes seems like a key use case. What about handling failures? Because distributed systems, they fail.
Always the challenge. And that's where one of the big strengths came in. Those built-in retry capabilities.
Well, yeah.
Anyone who's written code, to handle flaky networks or services knows how fast that retry logic gets messy, gets tangled up in your actual business logic.
Oh, it absolutely pollutes your code. Drives me nuts.
Precisely. Step
Yeah.
functions lets you kind of externalize that. You define right there in the workflow which errors should trigger a retry. How long to wait between tries to back off and how many times. It really cleans up your application code.
But you still need to be smart about it, right?
Oh, absolutely. They cautioned, you still need to choose what you retry carefully. And, crucially, have a plan for when all the retries are, well, exhausted. What happens then?
Makes perfect sense. Shift the resilience logic out. What about efficiency? Did it help with doing lots of things at once? Concurrency?
Definitely. Yeah, if you have a task that needs doing for many items, think like securing inventory for every single item in a big order.
That can take ages one by one.
Forever. They found that if you're already using step functions, adding that kind of concurrent execution is, well, surprisingly straightforward.
Oh, like using the map state, maybe?
Exactly that.
Yeah.
Using features like the map state, it lets you process a whole list of data entries in parallel. They even mentioned pairing this with custom retries inside the map state.
Really? Getting granular like that.
Yeah, so you get control over individual item failures within the batch. That was apparently a big win for speeding things up.
Nice. Any other good stuff that really stood out in practice?
There was one that sounds simple but is actually pretty powerful. The execute only once feature.
Okay.
For standard workflows, it gives you 90-day idempotency. If you try to start an execution with the exact same name and the exact same input as one that's already run or is running,
It just stops it.
well, it doesn't start a new one. It recognizes the duplicate attempt.
And why is that so useful in the real world? Seems specific.
Think about a client app. It kicks off a workflow, then maybe the user's phone loses signal before they get the confirmation back.
Ah, so they hit the button again.
Naturally. Without this feature, boom, duplicate execution. Could be a disaster, right? Depends what the workflow does.
Right, like processing the same payment twice. Ouch.
Exactly. So if you name your execution based on something unique like the order ID, the second attempt with the same name, same input, blocked automatically.
So it prevents duplicates without you needing to write custom detection logic at the start of your flow.
Yep, save teams a lot of headaches, apparently.
Okay, so let's recap the good. Built-in resilience with retries, easy concurrency, and that handy out-of-the-box idempotency. Pretty compelling.
They really are.
Yeah.
But like any tech that looks amazing on paper, there's always that dose of reality in production, isn't there?
Always. Which takes us neatly into what they called the bad.
Indeed. Prepare for the reality check.
All right, hit me with it. What was the first big hurdle they ran into?
A really significant practical limit.
Yeah.
The 25,000 event history limit per execution. for standard workflows, that is.
Okay, 25,000 events. That sounds like a massive number at first glance, but you're saying it translates to way fewer actual steps.
That's right. Every single thing,
Yeah.
every step, every retry attempt, every state transition, it generates multiple events in that history log. So maybe a simple Lambda state log, say 5 events. Suddenly that 25K limit means you can maybe only run through about 5,000 actual states in total, including retries and everything.
Oh, wow. So a really long-running workflow, or one that processes a huge list concurrently with map.
Or just one that has a lot of retries, because a downstream service is flaky.
It could just hit this limit and
Yeah.
stop, fail.
Exactly. The execution fails with an error. And that can leave your whole system in, an inconsistent state. Might need someone to manually fix things. It's a hard wall.
That sounds pretty bad, actually. How did teams deal with that? Were there workarounds?
They mentioned strategies, yeah, but they definitely felt like workarounds, not real solutions. One way was adding checks early on. Like, look at the input size, how many items in that list, and guess if it might exceed the limit. If so, fail it deliberately before it gets halfway through.
Fail early. Okay.
Another approach was to break it up. Deliberately design the workflow to start new, smaller step function executions partway through the overall process.
Starting new executions just to dodge a limit, that feels like adding complexity you shouldn't need.
It absolutely does. You're forced to design around a platform limitation instead of just focusing on your business logic. They definitely wish this limit was much higher, or maybe based more on state transitions, not every single little event.
Yeah, I can see the frustration there.
Yeah.
What else landed on the bad list?
Something they called the everything is a state trap. You know Maslow's hammer. When you get a cool new tool.
Means looks like a nail.
Yeah,
Yeah, I've been there. You get excited.
totally.
Yeah.
They saw this pattern where teams would take a process diagram, maybe a BPMN chart or something, and try to make a direct 1.1 mapping. Every box on the diagram becomes one state in the step function.
That seems kind of intuitive, though. You want the visual workflow to match your process chart.
It feels intuitive, yeah. But they found it often led to bad outcomes. One, increased cognitive load. You're managing inputs and outputs for every tiny little state.
Okay.
Two, potentially higher execution costs. Lots of tiny lambdas mean more potential cold starts, plus every single state transition has a small cost associated with it.
Right. The nickels and dimes add up.
And three, it could actually increase the total execution time because of all that overhead jumping between states, pre-processing, post-processing for each one.
So trying to perfectly mirror your flowchart and step functions can make it harder to manage, more expensive, and slower. That's counterintuitive.
Yeah, especially for complex processes. Their advice for better modeling was, okay, maybe start with that 1.1 idea as a rough sketch, but then step back and think critically. Group states together based on what they're actually doing.
Grouping. How do you decide what goes together?
The key distinction they found helpful was thinking about, is this state doing a write? Is it read only? And if it's a read, is it expensive or likely to fail?
Okay, write versus read and the cost risk of the read. How does that guide the grouping then?
The general guideline they settled on was states doing write operations. Usually keep those separate.
So you can use those built-in retries effectively if the write fails.
Exactly. You want to retry just the write itself if the database is busy or whatever.
Makes sense. Write stay separate for retries.
Right. Now, if you have read-only operations that are cheap and reliable, and the results are needed for a write that comes right after, you can often group those reads into the same state as the write. Because if that combined state fails later on the write step and retries run out, restarting the whole state isn't a big deal cost-wise, since the reads were quick and cheap anyway.
Combine cheap reads with the write that needs them. Got it. What about those expensive reads, calling a legacy system or something?
Yeah, if you have reads that are costly, hitting a third-party API with rate limits, querying a slow database, calling that old mainframe, they strongly recommended keeping those reads in their own separate states before any writes that depend on their output.
Why is that?
So that if a later write state fails and needs retrying or restarting, you don't have to rerun that expensive slow read operation again. You've already got the result from the earlier successful read state.
Isolate the expensive or risky parts. Okay, this is really shifting how you think about designing these things.
It totally is. The visual diagram is just part of it. You have to consider the operational side, cost, duration, reliability, does it change data, and design the workflow to really leverage step function strengths like retries while minimizing the state transition overhead.
So don't just translate boxes. Think about the action and its impact, and only use step functions where its features really give you a benefit.
Exactly. Don't force it if simple orchestration isn't needed.
That's super practical advice. Anything else in the bad that jumped out?
Yeah, one more. Out-of-order execution. Now, this isn't unique to step functions. It happens in lots of distributed systems.
Right, classic concurrency issue.
But it's easy to forget when you're looking at a nice linear workflow diagram. It can happen if, say, two events about the same resource arrive really close together.
Okay.
Because of things like Lambda cold starts, the second event might hit a warm function instance and finish before the first event, which got stuck waiting for a cold start.
Ooh, like two updates for the same customer record arrive milliseconds apart, but the second one actually updates the database first.
Precisely. If the order matters for that customer record, you could end up with inconsistent or wrong data.
Yeah, that could definitely mess things up. How did they handle that?
Well, they acknowledge there's no magic bullet. A common pattern is to serialize executions based on the thing being changed. Like, for orders, maybe use SQS FIFO queues.
Ah, first in, first out.
Yeah, and use the message grouped feature, setting it to the ordered. That forces SQS to deliver messages for the same order ID strictly in sequence.
But that adds complexity, right? Moving to FIFO queues, managing message groups.
It absolutely does. The source really stressed you need to figure out if that extra complexity is worth it for your case. Or maybe you can detect and fix out-of-order updates later. It's a trade-off.
True.
They also kind of mused that it would be fantastic if AWS offered some kind of built-in concurrency control within step functions for this, like only one execution per order at a time.
Oh, that would be a game changer for those sensitive sequences. Okay, we've navigated the good, the bad. Are you ready for the ugly?
Deep breath. Okay, yeah. Let's tackle the ugly. This was stuff that wasn't necessarily a showstopper, but felt suboptimal. Things crying out for improvement after using it heavily for a year.
What topped the ugly list?
Just the sheer tedium, really, of setting up error handling.
Tedium, how so?
Well, the building blocks are there, the catch config for errors, the retry config.
Hmm.
They're powerful, flexible primitives.
Ah.
But applying them for common expected errors across lots and lots of states, or maybe across multiple workflows, it gets incredibly repetitive.
I can picture it. Copying and pasting the same JSON block over and over again.
Exactly. Like, if you have a standard way you want to retry calls to service X because it flakes out sometimes, you have to define that exact retry policy again and again and again. They really wished you could define, say, default retry policies, or maybe named policies like standard APA service retry that you could just reference from different states or even share across state machines.
That seems like such an obvious improvement, like CSS classes for error handling.
Kind of, yeah. It would simplify the definitions massively.
Okay, what else felt ugly?
The developer experience. Specifically, the lack of a really smooth, robust local development setup.
Right. Getting that fast feedback loop by running stuff on your laptop is key for productivity.
It's crucial. And you can't run the whole AWS cloud locally, obviously.
No.
But you need some decent way to test your workflow logic and the lambdas or other services it calls without deploying constantly.
So what are the options now, and why are they ugly?
Well, they looked at the two main ones. First, using the serverless framework with AWS local stack.
Okay, popular combo.
Yeah, but the critique was it can be fragile, breaks when new versions come out, and importantly, the step functions emulation in local stack often relies on third-party plugins, which don't always have full feature parity with the real AWS service. So you run it locally, it works fine, you deploy it, boom, doesn't work.
Ouch, feature gaps and instability. That's painful. What about the AWS-provided local runner?
AWS local step functions, usually used with the SAM CLI. It's from AWS, which is good. But they felt the setup just wasn't simple or integrated enough, still kind of fiddly, and it also lacked full parity. A big one missing was running Sync Express workflows locally.
Ah, the faster, shorter duration ones, they're quite popular now.
Exactly. So you couldn't test those locally easily.
So whichever route you choose for local dev right now, it's kind of difficult and incomplete.
That was the takeaway, yeah. A definite ugly spot.
Yeah.
They basically expressed a strong hope for a more integrated AWS toolset, something that lets you run the workflow logic and your lambdas locally smoothly. Maybe with an easy way to hook into a cloud sandbox for testing interactions with other real AWS services when you need to.
An integrated local cloud dev story. Gosh, that would be huge. Not just for step functions, but for so many AWS services.
Absolutely. It's still a major challenge for cloud-native development overall.
Okay. So, after navigating the good, weathering the bad, and facing the ugly, what was the final verdict? The overall feeling from the author, the teams, after a year in the trenches?
Despite all the downsides we talked about, the conclusion was still pretty positive, conditionally. They felt step functions remains a genuinely good option when its core features those retries, the idempotency, the visual management, let you effectively shift complex coordination logic out of your application code and into the infrastructure definition.
So, when you're leveraging its specific strengths.
Precisely. They're optimistic. AWS will keep improving it. They do release updates frequently, and they really highlighted the value of sharing these kinds of real-world experiences just like they did in their write-up.
That feels like a really balanced, pragmatic take. It's not magic, not a silver bullet. But if you apply it thoughtfully, where it fits well, it can solve some tough distributed system problems more elegantly than rolling your own code.
Yeah, and knowing the pitfalls up front, that event limit, the modeling traps, the local dev pain, that's key. It helps you design around them or just make a more informed decision about whether step functions is even the right tool for the job.
Absolutely. Which brings us to a final thought for you, our listeners, to chew on, reflecting on this deep dive. How do you strike that balance in your own workflow designs?
Hmm.
You want that clear, readable visual diagram, right? But you also have to optimize for the messy realities of production cost, execution time, those hard platform limits we discussed. How do you design for both clarity and operational efficiency?
It's that constant tension, isn't it? Building robust systems, made very concrete by the specifics of a service like step functions.
Indeed it is. Something to think about. Now, you can find more details about the source material we discussed today down in the description.
And while you're looking there, why not subscribe for free to the Architecture Corner newsletter? We've got more deep dives like this coming up.
You won't want to miss it. We'll see you next time.